4.2.6 Simultaneous Equations Part 2 for Leaving Cert Maths, Higher Level Only. This video was produced by the UCD Math Support Center in conjunction with the UCD Access Center. So now I want to find the intersection point of equations with three variables, and I've got three equations. So let's label my equations again. 3x plus 4y minus 2z is minus 6, x plus 5y minus 3z is minus 15, and minus 2x plus 2y plus 4z is 10. So the idea here now is to eliminate one of the variables from two of my equations when I add them together. So I can choose any two variables and any variable to eliminate. So let's choose equations A and B. And then we're going to try and eliminate x. So how can we do that? So for the first equation, we can leave A as it is. For B, let's multiply it by minus 3. So I get minus 3x minus 15y plus 9z is 45. And now when I add those together, I get 3x minus 3x is 0. 4y minus 15y is minus 11y. Minus 2z plus 9z is 7z, and minus 6 plus 45 is 39. So I've got a new equation, and let's call that equation D. Now I take two more of my equations, and I eliminate x from them. So it's got to be two different equations. So let's take B and C this time, and let's see how we can eliminate x from those. So let's multiply B by 2 this time. I get 2x plus 10y minus 6z is minus 30, and C can stay as it is. Minus 2x plus 2y plus 4z is 10. And again, let's add them. 2x minus 2x is 0. 10y plus 2y is 12y. Minus 6z plus 4z is minus 2z. And minus 30 plus 10 is minus 20. So now let's divide that equation by 2 just to make it slightly easier. I get 6y minus z is equal to minus 10, and I'm going to call that equation E. Now let's take my new equations D and E, and now I want to see if I can eliminate either y or z from the two of them when I add. So it looks like z will be easier to eliminate. We can multiply equation E by 7. So I get 42y minus 7z is minus 70. Now when I add those two equations, minus 11y plus 42y is 31y, plus 7z minus 7z is 0, and 39 minus 70 is minus 31. So then y works out to be minus 1. And now I can solve for z and then x by subbing in y. So let's sub y equals minus 1 into E. We get 6y minus z is minus 10, so subbing in y is minus 1. I get minus 6 minus z is minus 10, so minus z is minus 4, and z is 4. And now I can sub in my values for y and z into any of my first three equations. Let's go with B. So I've got x plus 5y minus 3z is minus 15. I'm subbing in minus 1 for y and 4 for z. So I get x minus 5 minus 12 is minus 15, so x works out to be 2. So my intersection point then is now 2, minus 1, and 4. And I'm done.